Developing an end-to-end machine learning project. Even after passing the TensorFlow Developer Certificate Exam, I'd say that you can only really prove your competency with projects that showcase your research, programming skills, mathematical background, and so on. In my post How to Build an Effective Data Science Portfolio, I shared many project ideas and other tips to prepare an awesome portfolio. This post is dedicated to one of those ideas, building an end-to-end data science (ML) project. This tutorial is intended to walk you through all the major steps involved in completing an end-to-end machine learning project. For this project, I've chosen a supervised learning regression problem. To go through this project and tutorial, you should be familiar with machine learning algorithms, Python environment setup, and common ML terminologies. Here are a few resources to get you started. List of tasks for almost every machine learning project. Keep referring to this list while working on this or any other ML project. That's it. So make sure you have an understanding of these concepts and tools and you're ready to go. The first step is to get your hands on the data. But if you have access to data, as most product-based companies do, then the first step is to define the problem that you want to solve. We don't have the data yet, so we are going to collect the data first. We are using the AutoMPG dataset from the UCI Machine Learning repository. Here is the link to the dataset. The data concerns city cycle fuel consumption in miles per gallon, to be predicted in terms of 3 multivalued discrete and 5 continuous attributes. Once you have downloaded the data, move it to your project directory. Activate your virtualenv, and start the Jupyter local server. The next step is to load this data file into a pandas datagram. For that, make sure you have pandas and other general use case libraries installed. Import all the general use case libraries like so. Next, look at a few rows of the data frame and read the description of each attribute from the website. This helps you define the problem statement. Problem statement: the data contains the MPG, mile per gallon, variable which is continuous data and tells us about the efficiency of fuel consumption of a vehicle in the 70s and 80s. Our aim here is to predict the MPG value for a vehicle, given that we have other attributes of that vehicle. Exploratory data analysis with pandas and NumPy. Since there are a few outliers, we can use the median of the column to impute the missing values using the pandas median method. The two categorical columns are cylinders and origin, which only have a few categories of values. Looking at the distribution of the values among these categories will tell us how the data is distributed. The pair plot gives you a brief overview of how each variable behaves with respect to every other variable. For example, the MPG column, our target variable, is negatively correlated with the displacement, weight, and horsepower features. This is one of the first things we should do, as we want to test our final model on unseen, unbiased data. There are many ways to split the data into training and testing sets, but we want our test set to represent the overall population and not just a few specific categories. Thus, instead of using simple and common train test split method from Sclern, we use stratified sampling. Stratified sampling, we create homogeneous subgroups called strata from the overall population and sample the right number of instances to each stratum to ensure that the test set is representative of the overall population. In task 4, we saw how the data is distributed over each category of the cylinder column. We're using the cylinder column to create the strata. You can compare these results with the output of train test split to find out which one produces better splits. The origin column about the origin of the vehicle has discrete values that look like the code of a country. We found acceleration on power and acceleration on CYL as two new variables which turned out to be more positively correlated than the original variables. This brings us to the end of the exploratory analysis. We are ready to proceed to our next step of preparing the data for machine learning. One of the most important aspects of data preparation is that we have to keep automating our steps in the form of functions and classes. This makes it easier for us to integrate the methods and pipelines into the main product. In order to make changes to datasets and create new variables, Sclern offers the baseEstimator class. Using it, we can develop new features by defining our own class. As I said, we want to automate as much as possible. Sklearn offers a great number of classes and methods to develop such automated pipelines of data transformations. The major transformations are to be performed on numerical columns. So let's create the numerical pipeline using the pipeline class. Standard scaling of each attribute, always a good practice to scale the values before feeding them to the ML model. Using the standard scalar class, we have the numerical transformation ready. The only categorical column we have is origin, for which we need to hot encode the values to the instance. Provide the numerical pipeline object created from the function defined above. Then call the onHotEncoder class to process the origin column. With these classes and functions defined, we now have to integrate them into a single flow, which is going to be simply two function calls. Evaluating the model using root mean squared error, typical performance metric for regression problems. Now, if you perform the same for decision tree, you'll see that you have achieved a 0.0 RMSE value, which is not possible. There is no perfect machine learning model. We've not reached that point yet. Problem: we are testing our model on the same data we trained on, which is a problem. Now, we can't use the test data yet until we finalize our best model that is ready to go into production. Cheeky learns k-fold cross-validation feature randomly splits the training set into k distinct subsets called folds. Then it trains and evaluates the model k times, picking a different fold for evaluation every time and training on the other k1 folds. The scoring method gives you negative values to denote errors. So while calculating the square root, we have to add negation explicitly. After testing all the models, you'll find that random forest regressor has performed the best, but it still needs to be fine-tuned. A model is like a radio station with a lot of knobs to handle and tune. Now, you can either tune all these knobs manually or provide a range of values, combinations that you want to test. Grid search CV requires you to pass the parameter grid. This is a Python dictionary with parameter names as keys mapped with the list of values you want to test for that param. We can also check the feature importance by enlisting the features and zipping them up with the best estimator's feature importance attribute as follows. We see that ACC on power, which is the derived feature, has turned out to be the most important feature. For deployment, we save our model into a file using the pickle model and develop a Flask web service to be deployed in Heroku. Let's see how that works now. A trained model ready to deploy, save the model into a file to be further loaded and used by the web service. A web service that gives a purpose for your model to be used in practice. For our fuel consumption model, it can be using the vehicle configuration to predict its efficiency. We'll use Flask to develop this service. A cloud service provider, you need special cloud servers to deploy the application. For simplicity, we are going to use Heroku for this. I'll cover AWS and GCP in other articles. Once you're confident enough to take your trained and tested model into the production-ready environment, the first step is to save it into a h5 or .bin file using a library like Pickle. It's time to test if we are able to use this file to load our model and make predictions. We are going to use the same vehicle config as we defined above. The next step is to package this model into a web service that, when given the data through a POST request, returns the MPG miles per gallon predictions as a response. I am using the Flask web framework, a commonly used lightweight framework for developing web services in Python. In my opinion, it is probably the easiest way to implement a web service. Flask gets you started with very little code, and you don't need to worry about the complexity of handling with HTTP requests and responses. The next step is to activate this environment and start developing a simple endpoint to test the application. The above code makes use of decorators, an advanced Python feature. You can read more about decorators here. We don't need a deep understanding of decorators. Just that adding a decorator at app.root on top of the test function assigns that web service address to that function. Opening the URL in your browser will print the response string on the web page. In this directory, create a ml_model.py file which will contain the data preparation code and the predict function we wrote here. Copy and paste the libraries you imported earlier in the article and the pre-processing transformation functions. The file should look like this. Now, In the main.py we are going to import the predict_mpg function to make predictions. But to do that we are required to create an empty __init___.py file to tell Python that the directory is a package. Next up, define the predict route that will accept the vehicle config from an HTTP post request and return the predictions using the model and predict_mpg method. Here, we'll only be accepting post request for our function and thus we have methods equals in the decorator. First, we capture the data, vehicle config, from our request using the getJSON method and store it in the variable vehicle. Then we load the trained model into the model variable from the file we have in the model files folder. We create a JSON response of this array returned in the predictions variable and return this JSON as the method response. We can test this route using Postman or the requests package and then start the server running the main.py. Then in your notebook, add this code to send a post request with the vehicle config. Great. Now comes the last part. This same functionality should work when deployed on a remote server. Create a prick file in the main directory. This contains the command to get the run the application on the server. Gunicorn is a pure Python HTTP server for WSGI applications. It allows you to run any Python application concurrently by running multiple Python processes within a single dyno. It provides a perfect balance of performance, flexibility, and configuration simplicity. Now, create a wsgi.py file and add. You can use pip freeze greater than requirements.txt or simply put the above mentioned list of packages plus any other package that your application is using. I named it mpg Flask app. It will create a Flask app and will give us a URL on which the app will be deployed. This was still a simple project. For the next steps, I'd recommend you take up a more complex dataset, maybe pick up a classification problem and repeat these tasks until deployment. Here is the complete tutorial in playlist form on my YouTube channel where you can follow me while working on this project. With this channel, I plan to roll out a couple of series covering the entire data science space. Here is why you should be subscribing to the channel. These series would cover all the required, demanded quality tutorials on each of the topics and subtopics like Python fundamentals for data science. Podcasts with data scientists and engineers at Google, Microsoft, Amazon, etc., and CEOs of big data-driven companies. Projects and instructions to implement the topics learned so far. Learn about new certifications, bootcamp, and resources to crack those certifications like this TensorFlow Developer Certificate Exam by Google. Learn to code for free. FreeCodeCamp's open source curriculum has helped more than 40,000 people get jobs as text source, freecodecamp.org.